Welcome to this class. Today I shall give you a short speech on correlation analysis. What does correlation refers to? Correlation refers to the relationship between two variables. It shows the degree of relationship. Also it shows the direction of change. Values of various variables are interrelated. Such variables are obtained in two series. Data obtained about price of a commodity and its quantity demanded. In such two series data, we get a relationship between them. When price of a commodity increases, quantity demanded falls. Similarly, when price of it decreases, quantity demanded increases. Data obtained about weights and heights of a group of persons. In such two series data, we get a relationship between them. Weight increases with the increase of height. Such relationship can be found in defined two series data like age of husband and age of wife, price of a commodity and quantity sold, and price of a commodity and quantity bought, and also consumption and income, and so on and on. Now, the correlation can be classified in the ways as simple correlation and multiple correlation, positive and negative correlation, linear and non-linear correlation. Simple correlation, it when we study the relationship between two variables, this is a simple correlation. For example, consumption and income. Here, consumption is a function of income. Consumption is dependent variable and income is independent variable. So with the change in income, consumption changes. So with the increase of income, consumption increases. With the decrease of income, consumption decreases. Thus, consumption depends on the level of income. So this is simple correlation. Now partial correlation. In partial correlation, we study the relationship between two variables when all other variables involved under study remaining constant. For example, study involves the variables of production of paddy, seeds, rainfall, and fertilizer. But if we study the relationship between production of paddy and seeds only, when rainfall and fertilizers are remaining constant, this is the case of partial correlation. Multiple correlation. If we study the relationship among all the variables, here the number of variables are more than 2. This is multiple correlation. For example, if we study the variables of production of paddy, seeds, rainfall, fertilizers, this is the case of multiple correlation. That is relationship among all the variables. Now, positive correlation. So correlation may be positive or negative. This depends on the direction of change. If two variables move in the same direction, this is the case of positive correlation. And if the variables move in opposite direction, this will be the case of negative correlation. Here, say there are two variables x and y. X here increases this way 2, 5, 9, 12, 16 and 20. With it, Y also increases this way 5, 10, 16, 20, 25 and 35. So here with the increase of X, Y also increases. This is the case of positive correlation. Now negative correlation. When two variables change in the opposite direction, This is known as negative correlation. Here, if value of a variable increases, with it value of other variable decreases. Again, if value of variable decreases, with it value of other variable increases. For example, here x increases, but with it y decreases. X increases this way 2, 5, 9, 12, 16, 20, but y decreases this way by 35, 25, 16, 9, 6, 2. So they are moving in opposite direction. This is the case of negative correlation. Now, linear and non-linear correlation. When the values of the variables change in the constant ratio, this is known as linear correlation. On the other hand, when the values of the variables do not change in the constant ratio, this is known as non-linear correlation. Here you see x increases by 2 this way 2, 4, 6, 8, 10, 12. Y also increases with it by 3 this way 3, 6, 9, 12, 15, 18. So here the change is change in the constant ratio. They change in the constant ratio. So this is linear correlation. In case of non-linear correlation, x increases um, here, for example, this way 2, 4, 6, 8, 10, 12 by 2, but y do not change in the same ratio. So this is the case of non-linear correlation. Now, the coefficient of correlation. So, coefficient of correlation is nothing but the measure of degree of correlationship. That is, the variables are related to each other, but to what extent? So, according to calculation, coefficient of correlation is denoted by small r, and the value of r lies in between +1 and -1. But the value of r exceeding +1 and less than -1, these are error. So r should be in between +1 and -1. So there are three indications of r, that is coefficient of correlation. Coefficient of correlation may be equal to +1, that is perfect positive correlation. It may be -1, that is perfect negative correlation, and r equal to 0, that is no correlation. You see, this can be explained in the figures. Here, this is shown in three figures. The first one is perfect negative correlation. When the values of two variables are plotted on a graph paper and they fall on a straight line, they form a straight line and form a trend. Here the trend is falling. This the straight line is falling from upper left hand corner to lower right hand corner. So this is perfect negative correlation. The second one, when plotted points do not form or do not form any trend, we don't find any relationship here between two variables. This means there is no any correlation between the variables. Here correlation coefficient equal to 0. In the third case, there is perfect positive correlation. Here the plotted points form a straight line and the trend is upward. This upward, that is from lower left hand corner to upper right hand corner. So here the straight line goes upward. So this is the case of perfect positive correlation. Now Karl Pearson's coefficient of correlation can be calculated by dividing covariance of x and y by their standard deviations. And this is the modified form, a modified formula to find the coefficient of correlation. So, how to find to this topic? This very brief explanation, just introduction. Okay, thank you.